This is Spacetime, Series 23, Episode 89. Coming up on Spacetime, mysterious movements in the heart of the Milky Way, new questions about the South Atlantic anomaly, and the space station has a leak. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have discovered mysterious cold, dense blobs of gas being shot out like bullets from the centre of the Milky Way. The findings, reported in the journal Nature, add a new level of complexity to the galactic centre, which is shrouded from direct observation by a veil of stars, gas and dust. The region is home to Sagittarius A star, the Milky Way's 4.3 million solar mass supermassive black hole, located some 27,000 light-years away. It's also host to giant orbs of gamma-ray generating hot gas, known as Fermi bubbles, which extend some 25,000 light-years above and below the disk of the Milky Way, and numerous other mysterious clouds and energy sources hidden from direct view. Like many other mysteries at the galactic centre, astronomers are yet to determine exactly how these gas blobs are being ejected. The observations were made using the European Southern Observatory's APEX Atacama Pathfinder experiment in Chile. One of the study's authors, Professor Naomi McClure-Griffiths from the Australian National University, says the findings could have important implications for the future of the Milky Way galaxy. McClure-Griffiths says galaxies can be really good at shooting themselves in the foot. When galaxies drive out a lot of mass, they lose some of the interstellar material that could be used to form new stars. It's a process astronomers call quenching. And if enough material's lost, then starbirth stops. McClure-Griffith says being able to see hints of the Milky Way losing the star-forming material makes her wonder what's going to happen next. The study also raises questions about what's happening in the galactic centre right now. In fact, the wind at the centre of the Milky Way has been a hot topic of debate ever since the discovery of the Fermi bubbles a decade ago. McClure-Griffiths and colleagues have observed not only hot gas associated with the Fermi bubbles, but also very cold, dense gas at the galactic centre, which is much heavier and so moves around less easily. It's still unclear whether Sagittarius A star has expelled this gas, or whether it's being blown away by the thousands of massive stars around the centre of the galaxy. The authors say it's the first time this process has been observed in the Milky Way, although it has been seen in other galaxies. However, the other galaxies exhibiting this process all have much larger supermassive black holes and star formation rates than the Milky Way, making it easier for these galaxies to expel material. Also, these other galaxies are, obviously a long way away, and that means astronomers can't really see them in much detail. McClure-Griffith says seeing the same sort of process occurring in our own galaxy provides astronomers with an opportunity to understand how these things work by looking at them up close.
What we found is very cold molecular gas flowing out from the center of the Milky Way. We've detected this with carbon monoxide emission from the APEX telescope in Chile. And this is sort of surprising because, for one, it's very cold gas in a very hot environment. And secondly, there's a lot of it. We're trying to understand why.
Carbon monoxide is often used as a surrogate to indicate cold molecular hydrogen gas, isn't it?
That's correct, yes. Directly detecting molecular hydrogen is very difficult, but it's the dominant molecule that we would expect to find, and carbon monoxide is just, as you say, a surrogate.
Tell me, is there a lot of this gas? What is it doing? Is it streaming out? Is it coming out in blobs?
Yeah, so what we found so far is a relatively small amount, but we've only looked in a very small area. So we had a sort of 100% detection threshold, and we found great big blobs. They're sort of like bullets coming out at high velocity up to about 5,000 light years away from the galactic center. But from these two blobs, and based on the fact that we found them in the two places we looked, we infer that there's quite a lot more.
The galactic center is home to Sagittarius A star, our local supermassive black hole. Do we think there's a connection there?
Well, quite possibly. But the problem is, so a supermassive black hole and ejection events that are associated with that we would expect disrupt these kind of molecular molecular clouds so that they just wouldn't survive as far out as we are seeing them. So you sort of expect you might see molecular gas within, a few hundred light years and maybe up to 1,000, but seeing intact, quite large molecular clumps out to larger distances is hard to explain if it was pushed out by the active galactic nucleus, but it's also hard to explain if it's pushed out simply by starburst, so with gas that's being pushed by the many, many massive stars in the region.
Is the temperature hard to explain as well?
It is, yeah. So as one of my colleagues said, it's like, snowballs coming out of a volcano. You're expecting gas that's 10 million Kelvin coming out of this galactic center region, and these are clouds that are 50 Kelvin.
Do we see similar processes elsewhere in the universe, around other galaxies, or inside other galaxies?
Yeah, well, that's a really good question, and that's one of the reasons why we did this study, is that we can look at it up close in our own galaxy and then take those lessons onto other galaxies. And certainly in other galaxies, we see starbursting environments, places that have 10 times the number of massive stars as the Milky Way. And they do often have molecular gas outflows, but they're much more powerful winds associated with those galaxies than what we see in the Milky Way. So we're a little bit perplexed in this case.
Because it's the cold molecular gas which is the birthplace of stars.
That's right, yeah. So presumably the molecular gas has been pulled out of the disk of the galaxy in the center where there are a lot of stars forming. And so it was a very molecular rich region. And then it gets launched outward by some process, which could be associated with the active galactic nucleus, or it could be associated with a starburst from more and more massive stars forming in that region. But the energetics of both cases are troubling.
Yeah, it sort of fits both, but doesn't really fit either well.
That's right, yes.
So what do you think's going on?
Well, that's the million-dollar question. I actually don't know. I really don't know. I think
Isn't that great?
It is. It's fun. I mean, I love a mystery.
It's exciting. Yeah.
And it's nice to be in a situation where we don't understand what's going on so that we can go look for more bits and pieces of clues and try to put it together. I expect that there's some bits of physics that we just haven't included. So, for example, if the clouds are wrapped up in magnetic fields, those can provide a bit of a shield and keep them intact for longer than they might have stayed intact otherwise. And that could allow for something like an active galactic nucleus to drive it outward with little magnetized shields, for example. So that's a possibility, but we don't really know.
Now, a couple of months ago, there was a study looking at a mysterious, strange cloud near the galactic center. It was thought that may have been associated possibly with the Fermi bubbles. And so
Yep.
we're seeing a lot of unusual features all in the same part of the Milky Way. Maybe our galaxy's center isn't as inert, isn't as quiescent as we thought.
I think that's probably true. I think it's definitely not as banal as we might have thought it was. While we don't have a super powerful
It's not an AGN.
black hole.
Yeah.
No, it's not an AGN, but it's still a reasonably large black hole, and there's probably been bursts of activity associated with it. And although we don't see a very high star formation rate at the center of the galaxy right now, that doesn't mean that there wasn't a higher star formation rate in the past. And so all of those things together could mean that we've had more activity in the past and created things like the Fermi bubbles than what we can see right now.
Has anyone been keeping track of the G clouds?
That's a good question. People have been. There was a bit of a sort of disappointment because they kind of just didn't
Yeah, the
do
great
most exciting thing that we thought.
Dr. Carl and I were most disappointed when nothing happened, when the G clouds
You
were
weren't
supposed
the
to be
only one.
gobbled up by the Milky Way's galactic center, by the black hole, and nothing happened. It was sort of, oh, okay.
Yeah, it was an absolute fizzer, but hopefully we'll find some other examples in the future to be able to track in. But I know that there are teams that keep an eye on all of the clouds around the galactic center and just trying to trace and see what's going on. But I don't think we're getting anything exciting coming up in the near future.
What are you guys going to do next about this? What's your next line of investigation?
Yeah, so we have an approved program on Apex to go and look for many, 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 many more molecular clouds. So we're going to cover a much larger area and try to get a large mass census. While we were able to extrapolate from the clouds that we did find to infer that there must be quite a large amount of molecular mass, we'd like to confirm that, going from a sample of 2, going up to a sample of hundreds. So that's the next step. And then also we have some members of our team who are doing some magnetohydrodynamic simulations of the galactic center and trying to understand if there are processes that can keep these gas clouds intact and as cold as they are that we haven't been including in all of those in the past.
That's Professor Naomi McClure-Griffiths from the Australian National University. And this is Space Time. I'm Stuart Gary. Still to come, new questions about the South Atlantic anomaly, and the International Space Station has sprung a leak. All that and more still to come on Space Time. A new study suggests the South Atlantic anomaly may be a recurring feature which has been around for up to 11 million years. The findings, reported in the Proceedings of the National Academy of Sciences, raise serious questions about the hypothesis, which points to the anomaly being a precursor to the next impending polarity reversal of Earth's magnetic poles. The South Atlantic anomaly is an area characterised by a significant reduction in the strength of Earth's magnetic field compared with areas at similar geographic latitudes. The anomaly causes Earth's inner Van Allen radiation belt to move closer to the planet's surface, dipping down to an altitude of just 200 kilometres. And this results in an increased flux of energetic particles in this region, exposing orbiting spacecraft to higher than usual levels of radiation. Since its initial discovery in 1958, the southern limits of the South Atlantic anomaly have remained roughly constant. However, a long-term expansion has been measured in the northwest, the north, the northeast, and the east. As the geomagnetic field continues to weaken, the inner Van Allen radiation belt keeps getting closer to the Earth's surface, with a commensurate enlargement of the South Atlantic anomaly at given altitudes. Now, while that's not having much of an effect on the surface, it is affecting those spacecraft orbiting above, because as we mentioned earlier, it's exposing them to more and more radiation caused by the trapped protons in the inner Van Allen belt. And that means significant signs of technical issues affecting spacecraft. Some spacecraft have simply had their circuits fried after flying through the region. Others face computer crashes. And so spacecraft operators need to consider the South Atlantic anomaly whenever they're flying in the region. The International Space Station has extra shielding specifically to deal with this problem. And NASA also takes special precautions with the Hubble Space Telescope, turning off key systems whenever it's passing through the anomaly. And it's not just technical things which are affected. Astronauts have also been affected in this region. It's caused a peculiar symptom known as shooting stars or phosphenes, which is seen in the visual field of astronauts, an effect termed the cosmic ray visual phenomena. It's caused by cosmic rays and other energetic particles actually travelling through the eyeballs of the astronauts. And if this new study is correct, the South Atlantic anomaly is something spacefarers will have to get used to. Scientists from the University of Liverpool studying the paleomagnetic record of the Earth's magnetic field suggest the anomaly's been around for a very long time. They looked at the geomagnetic record preserved in igneous rocks from the island of St Helena, which is located at the very centre of the South Atlantic anomaly. The record in the rocks, covering some 34 different volcanic eruptions taking place between 8 and 11 million years ago, all show the magnetic field pointing away from the North Pole, just as it does now. And that's interesting because scientists have been using the growing influence of the South Atlantic anomaly as a sign of an impending flip in Earth's magnetic poles. That's important because Earth's magnetic field's vital for life on our planet. It's a complex and dynamic force, shielding life from cosmic radiation and charged particles flowing from the sun and the solar wind. The magnetic field is largely generated by an ocean of superheated swirling liquid iron which makes up the outer core, around 2,900 kilometres below the Earth's surface. As the planet rotates, this acts like a spinning conductor in a dynamo, creating electric currents which in turn generate a continuously changing electromagnetic field. But this geodynamo is far from static, and it varies in both strength and direction, with polarity reversals or flips taking place on average every 250,000 years. However, the last flip was some 770,000 years ago, and so scientists believe we're well overdue for the next. And up until now, they've been using the South Atlantic anomaly as a sort of gauge to determine when the next polarity flip's likely. But based on these new findings about the age of the anomaly, that may not be such a good idea. This is Space Time. Still to come, astronauts aboard the International Space Station trying to find a leak, which is slowly venting atmosphere into space. And later in the science report, the first case of COVID-19 reinfection. All that and more still to come on Space Time. Astronauts aboard the International Space Station are trying to find a leak which is slowly venting atmosphere into space from the orbiting outpost. The leak has been isolated to the American portion of the space station. In the meantime, the 3 Expedition 63 crew members on station are isolating themselves in the Russian portion of the orbiting outpost. This consists of 5 modules: Zarya, Pirs, Poisk, Razvet and Zvezda, as well as the currently docked Progress MS-14 cargo ship and Soyuz MS-16 capsule. NASA says the leak was first detected back in September last year, but its intensity began increasing recently. So the crew are systematically sealing hatches in each section of the space station to try and track down the location of the elusive leak and patch the problem. Mission managers say the space station's atmosphere is maintained at a level of pressure comfortable for crew members. A tiny bit of air does leak out over time, requiring routine repressurization from the nitrogen tanks delivered on cargo ship resupply missions. But the last time there was a serious leak reported on the station was back in August 2018, when a hole was discovered in the orbital module of the docked Soyuz MS-09 spacecraft. Cosmonauts filled the hole with an epoxy sealant in order to plug the problem. Moscow launched a full investigation into the hole, but they've refused to release any details of their findings. What we do know is that the hole was clearly caused by a drill. That most likely happened during the spacecraft's construction, and then was poorly covered up with a bad repair job prior to launch. Prior to that, an air leak was discovered back in 2004. That was in a split in a flexible hose that forms part of the porthole system on the American Destiny module. It was quickly repaired with sealant. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. The first case of COVID-19 reinfection has been reported by Hong Kong University. A report in the Journal of Clinical Infectious Diseases claims a 33-year-old man was diagnosed with coronavirus more than 4 months after he recovered from a first bout of the disease. Genomic sequencing confirmed the patient had been infected with 2 different strains of the virus. Importantly, during the second infection, the man showed no symptoms. Scientists say that's in line with how immunity works. Even if you can get reinfected, your immune system's able to respond quickly enough because of its existing antibodies and T cells, and so you don't get sick. Still, even though the man showed no symptoms, he was still infectious, meaning he could still transmit the virus to others. Now, what that means is that herd immunity through natural infection may not be the best approach, which is where vaccinations come in. They're designed to mimic that first natural infection, but should protect both from getting the symptoms and, importantly, from transmitting the virus to others. The deadly COVID-19 coronavirus spread around the world from its origins in Wuhan, China. According to the World Health Organization, it's now killed almost 900,000 people, and it's infected more than 25 million globally. A new study has confirmed that the flammability of many landscapes around the world is increasing because of the combined effects of changing climate and land use patterns. A report in the journal Nature using 17 global climate models found that there will be a large increase in the occurrence of extreme fire weather over much of the planet, including southeastern Australia. The findings show fire seasons are lengthening, becoming more extreme, with lightning ignitions also increasing. But simply attributing these increases to climate change is challenging because there are other factors, including man-made ones, which shape the regional fire activity. However, despite these large uncertainties, researchers say that it's likely that the economic and environmental impacts of bushfires will worsen as a direct result of man-made climate change. New research has shown that some of our least favourite vegetables, such as broccoli, Brussels sprouts and cabbage, may be the most beneficial when it comes to preventing advanced blood vessel disease. A report in the British Journal of Nutrition found that high consumption of cruciferous vegetables was associated with less extensive blood vessel disease in older women. Using data from a cohort of 684 older Western Australian women recruited in 1998, researchers from the University of Western Australia found that those with a diet comprising more cruciferous vegetables had a lower chance of having an extensive buildup of calcium in their aorta, a key marker of structural blood vessel disease. The study found women who consumed more than 45 grams of cruciferous vegetables every day, that's about a quarter of a cup of steamed broccoli or half a cup of raw cabbage, were 46% less likely to have an extensive buildup of calcium in their aorta compared to those consuming little or no cruciferous vegetables every day. A new study has determined that the now extinct Tasmanian tiger or thylacine was in reality only about half as big as previously thought. A report in the Journal of the Proceedings of the Royal Society B found that the carnivorous marsupial reached an average weight of around 17 kilograms, rather than the 29.5 kilograms previously thought. Scientists from Monash University found there were strong differences in the average male and female body size, with thylacine males averaging about 19.7 kilograms and females 13.7. The thylacine is one of the ugliest chapters in European settlement of Australia. The marsupial was deliberately hunted to extinction by Tasmanian farmers who wrongly blamed the native animal for sheep loss. Benjamin, the last captive thylacine, died in the Hobart Zoo on September 7th, 1936. Astrology and horoscope columns remain a familiar feature in the tabloid press, in women's magazines and across the internet. Despite irrefutable scientific evidence that they don't hold any insights into personality, meaningful relationship or future events other than the gullibility of the reader, there are still a lot of people out there who are willing to be deluded by the meaningless predictions generated by those who pontificate over some imaginary relationship between celestial events and what happens in people's lives. And for the record, you're far more likely to be affected by the gravitational influence of a passing butterfly than what you are by some distant planet's position in the sky. Tim Mendham from Australian Skeptics says astrology and horoscopes are simply a coping mechanism used by people to deal with their everyday lives.
A lot of people believe in astrology. Whether they believe in sun sign astrology, which is the 12 zodiacs, 12 constellations of the zodiacs.
According to NASA.
Well, the 13 has been around for donkey's years. I mean, it's been known about it. It's nothing new. I don't know why NASA suddenly discovered it. Someone just announced that it was there, which I've always pronounced it Ophiuchus. Others are saying Ophiuchus, but yeah, Ophiuchus, which is...
Yeah, Ophiuchus is how I've always pronounced it.
Yeah, I've been a hard C. I'm, Greek background, is Greek language. But, that it's a snake. It's been there for ages. If you look at the zodiac, actually, the usual that they take up at roughly a month each is totally wrong, because the time there in the sky, in the sky, etc. Yeah, precession of the equinox is actually, they're all out by one star sign, not even allowing for Ophiuchus. But they're also different sizes. I mean, I think that Scorpio, it was only about 9 days when it's in the sky, the right place. I mean, there's others are 30 plus, right? So evening them out to 28 days or so, or 30 days, whatever, is totally wrong. And they have moved anyway. So the one you think you are not. And because working out with 13 star signs is a hell of a lot harder than getting nice patterns with 12, where you can divide them into threes or trines, as they call them, or sixes, or all sorts of things. So they've ignored the 13th one, even though it is a significant star sign in the sky. It's in there, behind the sun, as they call it, right, on the ecliptic, that it's there longer than a lot of the other accepted star signs. So,
what about the other 76 star signs? I mean, there are 88 constellations according to the International Astronomical Union.
But they're not along the ecliptic.
Oh, they've got to be
They're all up north and south. I mean, you know this, mate. You do an astronomy thing, so you tell me.
I do astronomy, not astrology. There's a difference.
Yes. I've had arguments with people as to which came first. Astronomy has to come first. You can't do astrology without looking at the stars and knowing where they are. I mean, you can't have alchemy without doing chemistry first.
So why do people still believe in astrology?
people under stress, people who are concerned about change to their lives, etc., people who are concerned about control over their lives. They look for something which is definite, which is explicable, which can explain what happens to them in their lives because of a particular influence, because they need certainty in their lives, and because lives are uncertain. It's the nature of living, is that there's a lot of uncertainties out there, and trying to find some reason for why things happen is difficult. And you try and find something in a chance world, and therefore astrology serves that particular purpose. There must be some people who are out there trying to look at the future, who are trying to see what do the stars say, what can I look forward to. But I think most people are just there to say, this is why you are what you are, or why you do what you do.
Trying to make sense out of the world around them somehow.
Yeah, I think so. And I think, there's many tools that people use to do that, and astrology is just one of them.
That's Tim Mindham from Australian Skeptics. And that's the show for now. Spacetime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download Spacetime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the Spacetime online shop and grabbing yourself a few goodies, or by becoming a Spacetime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more Spacetime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at Spacetime with Stuart Gary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.